Hello and welcome back. This is going to be our 9th lecture going from chapters 2.3 through 2.7. We're going to be talking about functions. Let's go ahead and jump in. So a set of ordered pairs x and y is called a relation in x and y. The set of x values in the ordered pairs are called the domain, and the set of y values are called the range. Given a relation x and y, we say that y is a function of x if for each value x in the domain, there's exactly one value y in the range. Example, determine if the relation defines y as a function of x and state the domain and range. First, I'll state the domain and range. So the domain is going to be all the x values. I'm going to start with the smallest value. That's going to be -4. The next smallest value is going to be -1. And then we have 2. And then we have 3, and it's listed twice, but we only need to write it once. And now for the range, we'll have, let's see, the smallest number is going to be -4. Then we have 0. Then we have 1, and then 2, and then 5. Now to determine whether or not this relation is a function, I'm going to draw a picture. So we'll have the domain over here, which is -4, -1, 2, and 3. And then we'll have the range over here, which is -4, 0, 1, 2, 5. All right. And then according to our ordered pairs, -4 is going with 2. And then -1 is going with 0. And 2 is going with 5. And then 3 goes to both -4 and to 1. So then if we go back and we look at the definition of a function, and it says it's a function if for every x there's exactly one value of y. However, looking at this 3 is assigned to two different y values, a -4 and a 1. So this would not be a function. All right. The vertical line test. So consider a relation defined by the set of points x and y graphed on a rectangular coordinate system. The graph defines y as a function of x if no vertical line intersects the graph in more than one point. For example, here's my y, here's my x. So let's say I have this function here. So what we would want to do is just start by drawing some vertical lines. We can see that each vertical line is going to intersect my graph at exactly one point. So this is a function. Let's do another example. Let's say we have this function. And let's go ahead and start drawing some vertical lines through it. We can see over here we're doing all right. But once we get here, I have 2 crossings, and then it kind of gets worse. So I have 4 here, 4 here, right? So my vertical line is intersecting this function at more than one point. So this would be not a function. So some important notation. The equation y equals x minus 2 defines y as a function of x. In function notation, y equals x minus 2 is written this way, where f of x is read as f of x. This is not multiplication. Very important. It is f of x. So we have f is the name of the function. X is the input variable from our domain, and f of x is our function value or y value that corresponds to x. So given the function f of x equals 2x plus 1, find the following. F at -2. All this is saying is everywhere we see an x, we're going to replace it with a -2. So f of -2 is equal to 2 times -2 plus 1, which is -4 plus 1, which is -3. Next, f of 0. This is going to be 2 times 0 plus 1, which is 0 plus 1, which is just 1. And then f at 1 is going to be 2 times 1 plus 1, which is 2 plus 1, which is 3. Okay? So if you wanted to write them as ordered pairs, you could write it as -2 comma -3, 0 comma 1, and 1 comma 3. Because these values here are our x values, and then they spit out our y values. All right, let's move on. Evaluating a function. Evaluate the function defined by h of x is equal to 3x squared plus 2x for the given values. So in this case, our function's name is h. All right, so h at -2. This is going to equal 3 times -2 squared plus 2 times -2. So I've just put that -2 everywhere that I see an x. This is going to equal 3 times 4 minus 4, which is 12 minus 4, which is 8. So h at -2 is equal to 8. You could also write it as an ordered pair, which would be -2 comma 8. So let's do something a little trickier. H of a. Again, here's my input, and I'm going to put this guy everywhere that I see an x. So this is just going to be 3a squared plus 2a. We are done there. All it's saying is replace all of your x variables with a's, and I've done just that. Lastly, x plus h. Again, all I'm doing here is taking here what's in the parentheses and putting it into my spots where I see an x in my function. So this is going to equal 3 times x plus h squared, because I'm just replacing this x here with what's in these parentheses exactly, plus 2 times x plus h. So now we want to square out x plus h. I'm going to do that over here in some scratch work. So x plus h squared is equal to x plus h times x plus h, which is equal to x squared plus xh plus xh plus h squared, which is equal to x squared plus 2xh plus h squared. So this is going to equal 3 times x squared plus 2xh plus h squared plus, and then we can distribute this 2 to get 2x plus 2h. Lastly, we can distribute this 3. So that's going to be 3x squared plus 6xh plus 3h squared plus 2x plus 2h. And we have no like terms, so we are done. All right, let's move on. Given a function defined by y equals f of x, the x-intercepts are the real solution to the equation f of x equals 0, and the y-intercept is given by f of 0. So we want to find the x and y-intercepts of the functions defined by f of x equals x squared minus 4. So let's do the x-intercept first. So it says the x-intercepts are going to be setting f of x equal to 0. Here, this is my f of x, so that's what I want to set to 0. So I'll have x squared minus 4 equals 0. This means that x squared equals 4. And then if I take the square root of both sides, I get x equals plus or minus the square root of 4, which is going to be plus or minus 2. So these are my x-intercepts. You could also write them as points, -2, 0, or 2, 0. Next, let's find the y-intercepts. So the y-intercept is given by f of 0. So f of 0 is going to equal 0 squared minus 4. So that means f of 0 equals -4. And you can write this as a point as well, 0, -4. Note that when we're finding x-intercepts and y-intercepts, if we're looking at y-intercepts, we're only interested in where the graph crosses the y-axis. That means the x-axis is going to be 0. I'm sorry, the x value is going to be 0, and we're only interested in its vertical movement. When we are looking for the x-intercepts, that means y is going to be 0 because we're only interested in the horizontal bits here. Okay, let's keep going. Find the domain of each function. So these are tricky to find the domain of because we have to remember that the denominator can never equal 0. So that means that 2x minus 5 cannot equal 0. That means that 2x cannot equal 5. And then we can divide each side by 2 to get x cannot equal 5 halves. We can write this in set builder notation, where we'll have x such that x is a real number, but cannot equal 5 halves. All right, the next one says x squared plus 4 cannot equal 0. Well, by subtracting 4, I get x squared cannot equal negative 4. So the next step would be to take the square root of both sides, and then I would get x cannot equal plus or minus the square root of negative 4. But you can't take the square root of a negative in a real number system, because in the real number system, we don't consider imaginary numbers. So you can't say, oh, this is just, I times the square root of 4. We're really not interested in that when we're graphing. We only want real numbers. So this would actually be the domain, all real numbers, because there is no x to make this statement true. So you could also write that in set builder notation, x such that x is a real number. All right, let's move on. A linear equation in 2 variables. So let a, b, and c represent real numbers such that a and b are not both 0. A linear equation in the variables x and y is an equation that can be written in the form ax plus by equals c, and we call this standard form. So for example, if you had 2x plus 3y equals 7, that would mean that a is 2, b is 3, and c is 7. All right? So the slope of a line passing through distinct points x1, y1, and x2, y2 is defined here, where we have m equals y2 minus y1 divided by x2 minus x1, provided that x2 minus x1 is not 0, since we cannot divide by 0, right? So let's do this example. Find the slope of the line passing through the points -3, -2, and 2, 5. So this is going to be x1, y1, and x2, y2. All right, so let's start plugging these in. So that means m is going to equal 5 minus -2 divided by 2 minus -3, which is going to equal 5 plus 2 divided by 2 plus 3, which is 7 over 5. So this is our slope. Not too bad, right? Let's keep going. So now I want to talk about the slopes of vertical and horizontal lines. So first, let's graph the line y equals 3. So we'll have 1, 2, 3, because this is our y and this is our x. And what it's saying is that no matter what x equals, y is always going to be 3. So let's say x equals 2. Well, looking back at our equation, y is still equal to 3. Let's say x equals -5. Y is still going to equal 3. No matter what x is, y is constantly 3. So this is our function. Now remember, you can also think of the slope as rise over run, if you prefer. And if we're looking here, the slope has 0 rise, and all it's doing is running, essentially, right? It's a horizontal line. The slope of a horizontal line is 0. So the slope equals 0 for all horizontal lines. Next, let's look at x equals 2. So x equals 2 is saying that no matter what y is, x is always going to be 2. So if y is, say, 4, I look back at my equation and I see, oh, x still equals 2. If y is -3, well, x still equals 2. No matter what y is, x is just going to consistently be equal to 2. So my vertical line. The vertical line always has an undefined slope. All right, let's move on. Given a line with slope of m and y-intercept 0, b, the slope-intercept form of the line is given by y equals mx plus b. Note that f of x equals mx plus b is a linear function since it has this x variable. However, f of x equals b is constant because there is no x variable. All right, example, given 3x plus 4y equals 4, write the equation in slope-intercept form. So 3x plus 4y equals 4. And then remember our goal is to have y equals stuff, essentially, right? Y equals mx plus b. So the first thing I'm going to do to get y by itself is subtract 3x from both sides. So now I have 4y equals -3x plus 4. Next, I need to divide every term by 4. So I'll have y is equal to -3/4 x plus 1, since 4 divided by 4 is 1. Now that it's in this form, I can directly see that my slope is -3/4, and my y-intercept is going to be 0, 1, since the y-intercept is given by this number, which we call b. All right, let's move on. Example, write the equation of a line that passes through the point 2, 3 and has a slope of -4. All right, so that means my m equals -4, and then I have x, y is equal to 2, -3, and I can rewrite this as x is given by 2, y by -3. So now, looking back at my slope-intercept form, y equals mx plus b, I have 3 letters I can plug in. So my y was -3 equals m, which was -4, times the x, which is 2, plus b. And I'm going to solve for b. All right, so I have -3 equals -8 plus b. I'm going to add 8 to both sides to get 5 equals b. So now I found my y-intercept, and I can write the equation of this line. So remember, the equation of a line is y equals mx plus b. You could also write it in standard form, but I don't see the need to do that. So I'm going to write it in slope-intercept form. So this is going to be y equals -4x plus 5. And all I did was plug in the value that I was given for m up here, and the value that I found was b. All right, let's move on. Given the function defined by f of x equals x squared minus 1, determine the average rate of change from x1, which is -2, to x2, which is 0. All right, this is kind of tricky. We need to remember that whenever we see the words average rate of change, all it's telling us to do is to find the slope. So don't let that confuse you. Average rate of change is just slope. So we want to find the slope from -2 to 0. Well, the equation for slope was y2 minus y1 over x2 minus x1. All I'm given are x's, so I need to find my y1 and y2 before I can find the slope. All right, well, plugging in the x1, so f of x1, which is going to be f of negative 2, which is negative 2 squared minus 1, is going to be 4 minus 1, which is 3. So 3 is going to be my y1. Next, I'm going to find f of x2, which is going to be f of 0, which is 0 squared minus 1, which is just 0 minus 1, which is just negative 1, and that's going to be my y2 value. So f of x1 is y1, and f of x2 is y2. So now I have the slope is equal to negative 1 minus 3, using these two values I found for y1 and y2, divided by x2 minus x1, which is 0 minus negative 2. A lot of negatives there. So this is going to equal negative 4 over 2, since a negative minus a negative is a positive. This is going to be negative 2. So this is your average rate of change. I.e. the slope. Okay? All right, let's move on. The point slope formula for a line is given by y minus y1 equals m times x minus x1, where m is the slope, m is always the slope, and x1, y1 is the point on the line. So we want to use point slope formula to find an equation of a line that passes through the point 2, negative 3 and having a slope of 2. So all I'm going to do is plug all of this directly in. So my point x1, y1 is going to be 2, negative 3. So that means x1 is going to equal 2, y1 is going to equal negative 3. And then my slope, which is m, is going to equal 2. So now I'll have y minus negative 3 is equal to 2 times x minus 2. All right, minus a minus here will make this a positive 3, equals, and then I'll go ahead and distribute this. So we get 2x minus 4. I'm going to go ahead and leave this in slope-intercept form and just move this 3 over here. So I'll have y equals 2x minus 7. Not too bad, right? Let's keep going. Example, use the point slope formula to write an equation of a line passing through the points 4, negative 6, and 1, 2, and write the answer in slope-intercept form. All right, so the first thing we need to do is we need to notice that we weren't given a slope. So we need to find the slope. So here's x1, y1, x2, y2. So I'll have 2 minus negative 6 divided by negative 1 minus 4, right? This is going to equal, a minus is a plus, so we'll have 8 divided by negative 5 is my slope. Now to write it in point slope form, it doesn't matter which point I choose. I was given 2 points, and generally I pick the one with smaller numbers just to make my life easier. So I'm going to pick negative 1, 2. So that means I'll have y minus 2 equals negative 8 over 5 times x minus negative 1. All right, so now I have y minus 2 equals negative 8/5 x plus, oh, sorry, minus and minus is plus. So we get plus 8/5. Oh, nope, I'm wrong. So let's start from here. So equals negative 8/5 x plus 1 since a minus is plus. So this is going to be y minus 2 equals negative 8/5 x minus 8/5. And then what we'll need to do next is move this 2 over. So plus 2 plus 2. And now to combine a whole number and a fraction, we just need to figure out how we're going to get the 2 in terms of fifths. So it's going to be negative 8/5x minus 8/5. And then remember that 10 divided by 5 is equal to 2/1, right? So this will be plus 10/5. And finally, we can add these two fractions. So we'll get plus negative 8 plus 10 is 2/5. All right, and that's it. Next is parallel and perpendicular lines. If M1 and M2 represent slopes of two non-vertical parallel lines, then M1 equals M2. So all this means is parallel lines have the same slope. If M1 and M2 represent the slopes of two non-vertical perpendicular lines, then M1 equals negative 1 over M2. So this is negative and reciprocal. So for example, if I have my slope as 2, a parallel line will also have slope 2, but a perpendicular will have slope negative 1/2. You see, so negative and flipped. If I have slope a third, a parallel line will also have a slope of a third. However, a perpendicular will have a slope of, I need to make this negative and flip it. So the reciprocal of a third is just 3. All right? Okay, let's keep going. Write an equation of a line passing through the point 2, negative 3 and perpendicular to the line defined by y equals 1/2 x minus 4. All right, so what we need to do, so it's perpendicular. So what we need to do first is find our new slope. So the slope of my current line is 1/2. So my perpendicular slope is going to be negative and the reciprocal of 1/2, which is just 2. All right. Now I wanted to pass through the point 2, negative 3. So if I have my y equals mx plus b, then my m is going to be negative 2, x is 2, getting that from this point, and my y is negative 3. So I'll have negative 3 equals negative 2 times 2 plus b, which means negative 3 is going to be negative 4 plus b. And then I'll add the 4. So I get 1 equals b. So now I can write an equation of this line because I found a value for b. So I'll have y equals negative 2x plus 1. This line is going to be perpendicular to y equals 1/2 x minus 4. And it has the point negative 3. So we're going to pause here, and this is going to conclude part 1 of lecture 9. Please come back and watch the other part of this video, but thanks so much for tuning in this far, and I hope you have a wonderful rest of your day.